just did it out of solidarity. I think there was one person in there I didn't know. That was kind of nice in a way. Before we get started, quick show of hands. Does anybody not know Python? Okay. This should be followable for you. The one time we go kind of a bit deeper into some Python syntax, there's a bit of a little primer, which we'll see what we're doing for time. I didn't have time to time this tutorial. So we're just going to see how we go. We'll play it by ear. There's a few detours we can skip or not skip as we feel free. Hopefully you'll be able to keep up if you're not a Python programmer. There's a tiny little bit of JavaScript as well, but I promise it's not tricky. Is anyone here not a web programmer?
I'm not really, but how do you define a web programmer that pretends to be one?
Yeah, that's fine.
A programmer is not a web programmer.
Sure.
For linear instructions, is it all Python 2?
Also, yes, it's written in Python 2.7 because I left this too late to port all the depths up to 3.
Is there a function called find out what Python?
Python-v will tell you.
This is recorded as well, so I don't know about everyone else, but I prefer to be covered as much as you can.
Sure, we will cover as much as we can.
Because we can always go back into the
Yeah.
video later.
Like I said, there are a few detours in the slide deck, which, based on how we're going for time, we'll see how quickly we rush through them.
I'm having trouble loading the repository.
What does it say?
The first one said unable to connect, connection timed out. The second one, when I tried HTTPS, said 403 forbidden. Everyone else climbed it today?
You are connected to the Wi-Fi, right?
Maybe just start disable and enable your network.
Not going through a proxy. Have you tried turning it on?
Go to university.
I'd not tried it over HTTPS. I would have.
Just maybe disable and enable your network.
Yeah, I would have thought it would have worked over HTTPS. I apologize for GitHub. Cool. Ideally, you'll be on the branch example 1, but we'll get there when we get there. Are we good to go? AV people?
Just leave that URL at one.
Yep, I'm going to do that. So hi, everybody. Welcome to Flask 101. Before I begin, I'd like to take a moment to acknowledge the traditional owners of this land, the Noongar people. I want to acknowledge their elders past and present, and anyone who's here today who is an elder of the Noongar Nation. So my name's Danielle Madeley. I'm a programmer. I realized the other day I'd now been a professional programmer for a decade, and that kind of blew my mind because I'm not that old. I've been programming Python since I was 15, when I learned Python by taking a copy of the tutorial on the syntax reference to school and writing Python by ruling indents across my page, then going home and typing it in and seeing it would have executed. So maybe I have a Python VM in my head. I probably don't. I work for a company called Infoxchange. We're a not-for-profit in Melbourne. We do technology for social justice. What this means is that we produce apps, usually on the web, to help community public health organizations, usually paid for by the government or sometimes by the organization themselves, depending on how much money they have. Can I move on from here? OK, good. This is what we're going to be covering. I just ripped this off from the abstract. It's not quite in this order because when I wrote the talk, I found the order doesn't quite make sense. So what is Flask? Why would we use it? The very quick hello world. Then some interesting stuff around form processing, using SQLAlchemy as your ORM, object relation manager. Writing your first RESTful API. We kind of gloss over that a bit more than I would have liked. Doing cool stuff by holding connections open, which nowadays has very much been replaced by WebSockets, but we won't go into WebSockets, unfortunately. Testing, the most important thing. If anyone's seen a talk from me in the last year, it would have almost just guaranteed been about testing something somehow. And finally, we'll do a deployment to Openshift, because nowadays, who runs their own boxes? Sorry. The way this talk came about is I was working on an application, and this was 2012, and honest to goodness, it was still using CGI. It was executed as CGI scripts. And the performance was woeful because we were executing it up, loading the Python state, running the thing, writing it all out to a buffer, dumping it again. And just like, no, there's better ways. The first thing I said was, why didn't you use a framework? And they went, oh, Django is too heavy. I'm like, well, it comes with a lot of stuff. I wouldn't say it's any heavier, but there's a lot of stuff in the box. So Flask is not that. If Django is to come batteries included, then Flask is just the batteries. It's not even the toy car. Out of the box, Flask can do request, response, templates, and URL routing. Everything else you might want, form handling, databases, REST, that sort of thing, all via extensions. So it does have a very rich extensions API. Please come in. There's space over here if you need. So it does have a very rich extensions API. And as you'll see, we'll go through and use that to do some of the cool stuff that we're going to do. So that's cool. Flask is a WSGI application, WSGI, which I've also heard pronounced whiskey, but then I didn't know what they were talking about. I thought they meant the delicious brown liqueur. So as a result, in order to run a Flask application, you're going to want, or in production, you're going to want an application server. You're going to want, say, Apache with mod WSGI, or GUnicorn, or GEvent, or UWSGI. There's a lot of choices. However, it's also very easy. Python comes with a built-in WSGI development server that will handle requests. Nice thing at WSGI is it provides a common interface for all the myriad of different ways web apps could conceivably talk to things. So if you don't like mod WSGI, or you don't like any of the modern app servers, you can talk fast CGI or something else still via the same API to the web server of your choice. We won't go too much into, well, we won't go at all into the production side of that sort of thing. But it's pretty well documented if for some reason you weren't using something like Openshift or Heroku and you wanted to spin your whole stack up from the ground. While I'm on the stack, if you follow the instructions on the README, you'll have set up a virtual environment called virtualenv. Is anyone not familiar with virtualenv? Okay, virtualenv is just kind of a way to have a little pre-packaged Python environment. It won't pull in non-standard libs from outside Python. So you'll get your standard Python API, but all the other random system stuff won't be there to make a mess of your day. And everything you install will be installed in that local virtual environment, so you can't make a mess of anyone else's day. And then you'll have this nice little self-contained thing to do your work. Administrators hate it because it becomes very hard for them to update packages when they get a CVE. So this is the boilerplate. So we instantiate a Flask object, and then we'd say if we're running, name equals main, then just run the Flask object. And this will start Python's little built-in WSGI server. Again, never in production, but fine in dev. So this then becomes our very first hello world response. So you can see we write a function for our response, and we decorate it Does anyone not know what a decorator is? Oh, excellent. We decorate it to say we want to put it at the URL slash. If we then fire up our little server, so you should have already done the first couple of lines. If you just run the application and you go to the URL that it gives you, ideally it just works. So I've very stupidly lost my window and not in mirror. This is where it all falls down. Oh wait, I've got it. No, I don't. Because I've got the notes on my screen. Oops. So if we look here, we should have a web app directory. There's a lot of PYC files. Awkward. Yeah, I did. Thank you. Yep, so you can see here we've got this init py. So if I just run that. It's going to start running this basic dev server. Nice thing about this dev server is when you change your code, it will nuke all your threads and reload. As long as your threads aren't serving a request. If they're serving a request, they won't reload. Mostly not a problem, but can be. Okay. So we can chuck in a few more responses. We can just go nuts with whatever we need here. We can obviously do things. We can do redirects. We can render templates. You can basically return whatever you need. You can set the MIME type. I'll show you some examples of setting the MIME type on a raw object later on. So templates. Templates in Flask use Ginger 2. If you don't want to use Ginger 2, you could use something else. But the render template helper uses Ginger 2 by default. Like I said, you can replace it, but Ginger 2 is pretty good. So by default, it looks for them in the templates directory of your package directory. Again, you can change this, but I don't know, that's pretty useful. So yeah, example 2 is just going to do the same thing and show you using a template. So we can where's my window gone? So you can see go here, and then I go, we can get the same thing as a template. And then the Ginger 2 template, which we'll just, can everyone see this window, by the way, or should I make this bigger? So this is a very basic template, which is just literally HTML. What we can then do is add variables and other data to this. We can apply filters, which we will come to. So the next kind of thing you do, you've got stuff coming, you've got a hello world. So now you want to handle some input on the web. You've got a few options. Put it in the URL, put it in the query string, put it in a post request. So query strings are pretty easy. We can get an object called request, and we can have a look at request.args. And this is the value of the name key in the query string. It seems a bit weird, perhaps, if you're a object-oriented programmer, to have this global object called request, and then look at that. But it's kind of the way it works. Request will always be your current request you're handling. That way you don't have to mess about with passing it through. They decided that you almost always need to interact with the request object, and passing it 25 layers deep into your call tree or adding it to a class so that you always had it was, I guess, unnecessarily burdensome. So they decided they would just do this. Yes?
I'm just trying to get my head around the concurrency with multiple requests happening at the same time and talk about it global.
It's not really global, is the part to understand. It's magic. So the concurrency works. When you make requests to request, they're proxied to your actual current state. So the type of object it's called is like a Werkzeug proxy. Werkzeug is the underlying foundation layer. And it will make it work for you.
As I understand it creates a per thread object. You're actually referencing a per thread object.
Yes.
Even though it looks like a global object.
It's actually a per request object.
Oh, per request, yes.
And then either your requests are threaded or they're processes or they're co-threads, whatever magic you happen to be into. Do you know I don't know in Flask? I've never tried.
Could you repeat the question?
Are they read-only was the question. Some parts, we won't actually, I don't think I have an example of it. There are some other objects that you can get. There is session, which is obviously stuff related to the session. You can write to that, and it will, like in certain cases, say pop out into the session cookie. So you can add information that way. There's also an object called G, which is it's magic global data that you want to hold on to for the lifetime of the request. And so unlike the session cookie, which has to serialize your data out and back in, but lives forever, the G object just lets you store Python-esque things for the lifetime of the request. You can use it to do some dirty stuff.
Request isn't read-only, that was the question.
Okay, it is not read-only, there we go. So if you think query strings are kind of dated, which I do, there's also this syntax, which I'm quite fond of. So you can say root / item / angle of braces int : variable name, or stir : variable name. Or actually anything you want, you can register new ones, but by default it has kind of those basic types there. This then pops out as a variable to your method, and you can do what you need to do with it. So this way you get those nice kind of properly resourcey APIs. So you can have /user /Danny /pull request /15 and have it all pop out. So this kind of thing is always a pain, because obviously before, if we went request.args OU, we'd get just the first one. So if you want all of them for some reason, if you don't want someone to just sit there tacking things on and maybe somehow exploit your app because you're expecting a single one and suddenly you've got a list, then it just gives you, I can't remember if it gives you the first or the last. Here I've said it gives you the first. I have a feeling that Django and Flask are backwards and Django gives you the last. But anyway, it'll give you one. If you just ask this, it will give you one item. To stop that thing, we have to check, well, is it a single? Is it a list? Or the thing you have to do in Python's CGI module, which is always just go list bracket 0 bracket, because that's kind of annoying. If you ask for a thing that's not present, then you get a key error. There is, however, this get list, which feels like it should do what it says on the tin, which is return the whole list of them. But then what secretly catches you out, or at least secretly caught me out a couple of weeks ago, is if you call get list on a key that isn't present, then it doesn't raise a key error, which is what I was expecting. It gives you an empty list. And so I had an exception for key error, and it was falling through my code and blowing up later because I was trying to consume this empty list. There's also a pop list, and you can also do pop. Trickily, if you pop something, you get a string, but all the other values go away. So I don't believe there's a way to just pop the individual values unless you call get list and then pop that list, if that's what you need to do. Get requests are great, but we can't encode massive amounts of data in them. So then, obviously, the other thing we care about is post requests. So it exposes this via a variable called form, or an attribute called form. And this works the same way. There's also an attribute called files, which we use for file uploads. I won't go into that. There's some pretty good examples in their documentation. But if we're having to go through and manually do all of this, because everything's going to be a string, all things that come in via that variable are strings, we don't know any better. So we're just better off just using a library and getting away from the world of hell that is type coercion, because otherwise we may as well have just done import CGI and suffered through it. So if anyone's looked at Django or Rails, they'll be quite familiar with this sort of thing. This is a very simple rego form, and I've said I want a text field. I call email. I want it to have the string email. And then when I handle my request, I just say, OK, it can handle the get method or the post method, so that I can retrieve the page and then post back to itself. And then this tricky bit here. So if the form was submitted and it validates, then we want to return the response success as a string. In all other cases, we want to return the template with the form object. And where this gets a little bit trickier again is the form object could be one of many things. If they made a GET request, the form object will be a blank form with all the bits and pieces set up. If the form object, if they made a POST request and the form object contains data, but the data wasn't valid for some reason, then we return the form object with the data and with some errors. So you can see here, when we return the response, we're passing a variable into the template. The other thing that you'll see here is that we've now just set a secret key. We use this secret key for a few things. One of them is to encrypt our session cookie. and the other is to sign a CSRF token. CSRF, if you're not a web developer, is cross-site request forging. It's where somebody proxies your page and then sends a result back so they can do an attack against you in the middle. The idea would be that they wouldn't have that token set as a cookie because we generated it for this user and gave it to them as a cookie, and the single domain policy means they would have a different cookie. So these app secrets are actually really secret. Without them, people can launch attacks against your site. So you shouldn't actually ever have them in source code. I put it here just to make it work. Ideally, your app secret is being provided to you by something, and a config file that's generated for the server or on the fly. Yes?
And that's unique for your application, or it's on a per session basis?
It's unique for your application.
So you have one of them, and you install your application, and this year and 5 years from now, in theory, the secret's still the same?
Yes.
Okay.
But the token is different every time.
The request token is different every time. We just use the secret to encrypt it.
So it's the same.
Right, to sign it so you can tell that no one else has. Okay.
Yeah. So ideally, these are provided for you by somebody else. Don't put them on GitHub. If you put them on GitHub and nobody overrides them, your app, where it's installed, will be compromised. And someone will start doing stuff to you, probably decrypting all your users' sessions and fiddling with them. Particularly if you do things like trust the session to tell the server what someone's auth credentials are. If that's not encrypted, or if the token it's encrypted with isn't a secret, I can decrypt it, change it to another user, re-encrypt it again.
Because you know the secret.
Yeah. And then play that back to the server and goes, oh, cool, you're admin. No worries. So here we use it because Flask will try to do cross-site request forgery protection, and we'll say, hey, there's no secret. I'll show you later on when we deploy to Openshift how to get that secret more safely. We can also chuck in some validators. Yes, I'm sorry, that does kind of fall off the screen. So this is the same thing. The email variable is a text field called email. It has two validators. This is a tuple. One of them is data required. So this field is required. The other being that it should be an email. WTF forms gives you probably about 24 of these. Otherwise, you can write your own. You will eventually write your own because you'll start having things that check between multiple things to check an overall condition. You'll be like, this date has to be after that date because it's the end date and that's the start date. That sort of thing.
Is there any built-in sanitization?
Sanitization
Of text that users have entered that ends up in your application? Is that the raw string that they've typed in?
Yes.
Okay. So if you want to add a sanitization layer, it's up to you to manage that?
Yes. So typically you would do that if you're displaying user text or user entered data, you would do it in the template. It's a good question. I didn't have a demonstration of that. The filter is called safe. I'll show you a filter later on, but that would then escape your data out. If you need to do something like take in raw HTML from CK editor or that sort of ilk of thing, and so you need to then display the HTML unescaped, you will need to write your own field that passes it through LXML's HTML tidy or something. That is a classic mistake that I see in code. One of our smaller sites got compromised that way because the guy just left it out. Yeah, so this is the raw data in the format that you've asked for it. So you said it's a text field, it'll come through as a string. If you ask for an int field, it will apply some sanitization, I guess, to get it to an int. in that if it contains things that aren't part of the integer, it'll just raise a validation error and say, what are you talking about? This isn't an integer. Okay, so this is now example 3. So this is the template that we have so far. This is the middle of it at least. So it's pretty easy. We're creating a form. We have a thing called form.email. And say we want the label. That's that bit we put in the string just here. And then we want the actual form widget itself, which is form.email. And then finally we have this thing, form.email.errors, which is any validation errors we have from that form element, which are basically just exceptions. Exceptions get raised in the validator, and it catches that validation exception and throws the string back. There's also the bit at the top, the hidden tag. This is the bit that handles the CSRF. So as well as giving you back the cookie for the request, it will also be written into the form. And if they don't match, then it knows someone's done something dodgy and manipulated your form or playing it from the wrong location. So by default, if you don't have that, Flask will just go and give you a 4 or 3, I think, 4 or something. You can turn it off, but don't. Yeah, it's one of those things that if you have a really legitimate need for not doing it, then I guess you could not do it. But instead consider writing a proper cross-origin API and talking to that. So that basically, I guess, sums up input. And so you've got a form, you've got some input, we've got the basis of an output template. It's pretty low tech. So let's store some data. I mean, this is kind of the other part. It's the big part of web apps, and it's the big part that a lot of people have always traditionally screwed up. Yeah, I honestly saw an app that we have shipping in production that has raw SQL in the query string. And I was just like, I wonder, oh, look at that, there's the table. I could just dump it out. Yeah, thankfully someone had denied drop. But I could just select arbitrary data. It had no protection. So SQLAlchemy is, I guess, the Python ORM. If you're not using the Django ORM, you're undoubtedly using Alchemy.
Does anyone else have a problem running the example 3? I get a module object has no attribute data field, data required. Sorry, if it's just me, then just ignore it.
Pip major requirements.txt.
Yeah, pip install -r requirements.txt. Sorry. It was a bit organic. I meant to move them all back to be in the first example, and then apparently I forgot. The idea would be that you had all the requirements when you started. Whoops. So yeah, Alchemy is like the de facto ORM. It has the nice property that it's unopinionated. It doesn't make assumptions about schemas or what they might look like. You can change the names of tables. You can change the names of columns. You can say, I want to call this in my Python object, but it's called this in the database. You can explain some quite complex relationships. Nowadays, you can do that in Django as well, but Django's assumption was always that it was going to create databases that match its idea of the world. Alchemy then has kind of also gone, well, let's make it a bit easier for people and add a lot more defaults. So this is using Flask Alchemy, which adds some of this extra default stuff back in to say, hey, 90% of the time, my column, which I've assigned to ID, is just called ID. My column that I've assigned to email is just called email. So Flask Alchemy also handles some other nice stuff like assigning database connections to execution threads in the pool, so you have the right number of cursors and you don't accidentally select somebody else's cursor, that sort of thing, suddenly screw up someone else's transaction. So this is a very basic model. Create a table called users in my database, contains some columns. The other thing I need to then do is I need to tell it where my database is. So SQLAlchemy provides a config variable, SQLAlchemy database URI, which looks like a reasonably standard database URI connection string that a lot of things will now give to you. So that's cool. We can then do our standard SQLAlchemy kind of things, so we can select for a user, that sort of stuff. You of course need to create the database and maintain the schemas, which this wouldn't have done for you. Doing that by hand is the worst thing ever. I never do it. Thankfully, Alchemy has a kind of side project thing called Alembic. Alembic is a database migration system similar to South in Django, or the built-in stuff in Active Record Rake in Ruby. It's confusingly called though Flask Migrate, not Flask Alembic. That's something else. I think it might be an older project. Apparently I had a detour at this point. That's cool. So up to now, we've just been calling app.run with our command, which is great. It lets us run the server. But if we want to do things like prepare content or update the database, we need to be able to do other things. And like the old hand Python people, and I guess the old hand C people go, oh cool, import op paths, let's do this. But somebody's already done it for you. So there's a pretty commonly used extension called Flask script. And this is the easiest instantiation of it. By default, it will give you two commands, shell and run server, which come with the kind of options that you would like to have. So now you can just do this, and then you can go, OK, /init py run server, and you'll get the kind of thing you expect. So you can see it gives you some nice help. Lets you do what you need to do. The reason we had that little detour is because lots of people have started to write command plugins using Flask script. So Flask Migrate has one of those, which will add all the DB management commands for us. So we can expand our example to this sort of thing. And we say, OK, if I run the DB command, then that will add some extra bits and pieces. So at this stage, what we want to do is go, OK, I want to initialize my migrations. This will create it says, what it's saying is I want to initialize this project to have database migrations. So it'll create a directory called migrations, and we need to add that. The next thing we'll do is capture the initial state of the database by creating a first initial migration. So db migrate says I want to create a new migration. It will try to look at your database. So all the database models you've created, it will try to go, what's new, what's changed, and try to create the file for you. It's not bad. It'll occasionally come up with problems. So that'll create the versions directory, which we need to add. And then finally, we say, OK, upgrade. And by default, that will upgrade to the latest version. But otherwise, it will not. That was very descriptive of me, wasn't it? Oh, I'm on the wrong branch, sorry. So you can see here, I have 2 migrations because this example 4, I've made 2 changes to the database. Once to add the initial schema, and then once to grow it. Migrations in Alembic are as a linked tree. It also then will write a version number into your database for you. So what happens. So if we it's over there. That's fun.
It didn't work until I sudoed it for some reason.
Oh no, I know what it is. I'm not actually in my virtual environment.
Yeah, I still had some problems with the client, so I'll try with sudo. Yeah, I had these problems.
So you can see now I have this db command. And if I go db current, it's going to show me where I am on my little SQLite database. I can then either choose to downgrade that or upgrade that or create a new migration. If I create a new migration, it'll come up as empty because I'm on the current version. If we have a look then, so you can see here in tables, besides the users table that's ours, we also have this table called Alembic version, which contains the metadata. So that's just a scalar of the version number. So we could downgrade. We can go both directions with our migrations. We can drop backwards. We can go forwards. Okay, so that's cool. And at this point, hopefully we have a working database. You should better run a DB upgrade and get to the latest version of a database, including all that initial stuff. It should take you as far as you need, including creating all the tables and that. Because this example used SQLite, it should just work. So we can tie then this together. We've got a model now which has some data in the database. We have a form. We could write a view that then sat there and go, okay, I want to copy this value of my form object to this value in my model, and this value of my form object to this value in my model. Or we can just put free. So this will say that for this database model, create a form. This constructor then can take arguments like what fields we actually want to create. It can also take arguments what validators we want, what sort of widgets we want. So here's to say, okay, I want to validate it, that it's an email. It already knows that it's required because the database definition says the field can't be null. So we know we have to write something in there. We can force it if we have to, if it could be null. But in this particular form, it can't be. But the options for that were quite documented. So at this point now, our little registration program will look like this. By default, if it's a GET request, we'll just pop the request out. Otherwise, if it's a POST request, we create the form, we try to tie the form to the object it comes from using the ID. We then attempt to populate the object from the form, and then we'll add it and commit the result. And then we'll finally redirect back to the registration page. So this is example 4, which where's my mouse gone? So this database has been around a while, so it says 19 users. So then try to add something invalid. It's going to produce that error saying, no, I'm sorry, you're wrong. Try to add something that is valid. Redirect it back to the page. We now have 20 users. If I select that database, you can see all the things. You can also up there see the ones that I added in before I had the validator. And at that point, they obviously got accepted, written into the database. This example is quite interesting because not only do we pass the form variable into the template, but we also now pass this lazily evaluated query. And what we can do there just up here is now we have that example of using a filter. So I've said, OK, I have this variable called users, and I can now filter that to get the number of users that are actually in there. And you hope that filter does something sensible with the SQL. Though this might be, at my day job, I'm a Django programmer at the moment, so I couldn't remember when I wrote this example. I'm pretty sure this is correct, but in Django, it catches you up. You have to call .count, which is a method. But at this point, it will lazily evaluate the SQL and call select count star for from users. So did you have a question at the back? No? OK. How are we going for time? About halfway through. Cool. So that kind of should give you the basis of writing fairly boring create update type application. At least hopefully connect you up with the docs so that you can kind of get your head around them and start doing the other kind of things you want to do. So I thought it'd kind of need to do some of the cool stuff, like emitting an event stream. So this is the kind of thing I'm thinking of here is, for example, in Facebook with its little notifications thing. And we're going to do push events. So I'm saying I'm not. So quick detour into generators. Does anyone not know what a generator is? OK. So a generator in Python is a stateful thing that produces results that you instantiate. And then every time you call next on a, or in Python 3 underscore underscore next underscore underscore, it will cough up another result. and it holds state. It's got a little state object in there. So when we write our function, like we can, instead of having to write a class and have it hold state and all this other stuff, we can write it as a function using the magic keyword yield. So this function is a generator that yields an infinite Fibonacci sequence. It will never end. It just simply sits there looping, 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 and just yielding more values, and yielding more values, and yielding more values. It is a full-blown Python iterable, which means we can iterate it. And obviously, it will never end. It will just keep yielding values, and this bit of code will not stop executing until you kill it. We can make it stop by dropping off the end of the function. You can also make it stop by raising an exception called stop iteration, which says just all things that consume iterators are meant to check for stop iteration. And if that gets raised, they go, oh, my generator exhausted itself. So I think technically in generator land, this actually raises stop iteration on you, but you don't have to know about that. And so this will generate n elements of the sequence and will end. Sorry, was there a question?
No, sorry, there was something, sorry. Okay.
So that's cool. It will do, at this point, what we expect. What's nice about Flask is that we can use generators to emit a response. If we need to, the most classic example is if you want to do a file download, the rookie mistake is to go, open file, cool, read all the contents and write them out. That is like CGI mistake 1. And typically, it just comes along that somebody opens a 480 megabyte file and your process blows up because it gets killed. In CGI, you can kind of just then do a splice and splice one file descriptor to the other. You can't do that in WSGI, but we can write a generator that will stream the data out in nice, easy to manage blocks. In fact, even more nicely than Python has a version of read that is a generator and will give you nice, easy to consume blocks as well. So you can just go for I in blah yield I, and it will just stream your file out for you. Or you can even just pass that generator as your response. But so we can use it to implement our event stream because we can just keep yielding events. So we have an example that looks like this. In this example, what's important here, besides the generator, is that we are obviously creating a raw response and specifying the MIME type. This is much like some of the other responses where this is the content as a generator. It doesn't have to be a generator. It can just be text or bytes, whatever it needs to be. If it's a generator, it'll go, oh, cool, I'll generate that for you. And then we can specify return data like headers, a MIME type, stuff that we need. So we have this generator. We very creatively called it generate, which will just, at this point, loop forever, yielding events. And I've kind of left get event like out of this implementation. And we'll generate this event stream object. Event stream is a W3C standard for a stream of events. It's basically data colon space, whatever you would like, 2 enters, and then another one, and then another one. And you just hold that connection open, and every time you want to emit, you just write data colon space and 2 enters, and it will come out. Some browsers support this natively, others you need a shim. But it's a nice way to emit a stream of events. The other tricky part now, is that we need to use a web server capable of handling multiple requests at once, because this example is going to hold our request open forever. So we need to say, cool, I want a threaded server that can handle multiple requests. But there's a trick. The server would like to gracefully finish your request, and this request will never end, because it'll just keep generating events ad infinitum. So this was kind of a little bit of a side in the implementation. We hook the server command to add some concept of when we want it to shut down. And then we add that into our solution. So our full solution, which annoyingly doesn't have a slide, so this is example 5, if you'd like to look on your own screens. So there's a few bits going on here that I've glossed over a little bit more than is probably fair. This is the part that we just had, which is that we try to get an event out of an asynchronous event queue. We wait for 1 second. If we don't, the call stops blocking, and we drop through with an empty exception, which we ignore. And then we go back and say, are we still running? Yes, cool, try for another second to get this event, which means this thread will wake up once a second to try to see if it has any events. To populate the queue, we use what's called a signal. Flask has signals when certain events happen, which we will find out about next time. I think it's next time we enter the request loop. So we can decorate this method to say that when we get the message flashed signal to execute this function, and so the message flash signal, so no, they exited another thread, that's right. So the message flash signal will be, a message flash is just whenever you call the flash command, which is just a way to put messages into the session buffer to be like, your object was saved successfully. So here we're using it for the event stream. So we can do something cool with it in some Ajax-y way and say your object was saved successfully. So we can push objects into this asynchronous thread-safe queue. And then in that other thread, we can pull them out and add them to the ongoing request object. I apologize if this is incredibly, incredibly vague. There's also just format message, just a thing to wrap it up in some JSON. So it just calls json.dumps and then the value of our message.
It's probably like a really trivial question, but
Yep.
in terms of checking the server every like 1 second or whatever, just check a queue to see if it's got any state in there. Is that how like it would be done in practice, or would it be like an event-based thing? Like, is it wasteful to check every second? Or?
It's not wasteful to check every second. Any computer ever, I mean, your computer has to wake up at least every 3 seconds because that's how USB works. There's enough wake-ups. This will do it properly. It'll say, is there something in the queue? Cool. Kernel, put me to sleep. And wake me up in either when something happens or in 1 second. We could, like the other solution to this problem is to write some magic object into the queue. It's horses for courses. I've seen people literally write stop iteration into the queue.
So that would be like needlessly complex, would you say?
Yeah, I find just occasionally every second going, oh, should I have shut this thread down? It's fine. Yes.
You probably want to repeat the command.
Oh, sorry. Yeah, the question was, is waking up every second bad? And the answer is that, to be honest, not really. You wake up more often than that anyway. That the kernel will just put you to sleep and wake you back up when something happens or in a second. And it's not even a very accurate second. Like, it'll wake you up in a second-ish when it wakes up. Because we're misusing the producer-consumer event queues, you also need to call this task done to make things disappear from the queue. We could write our own threaded or thread-safe queue implementation, but the standard library has this one, so why not use it? Does anyone have any more questions on this? Did I gloss over this too quickly? No? Cool. So the other side, I put this huge warning, and then I realized actually it's not that much code. Kind of just looks like this. So there's a very nice jQuery plugin which handles the W3C event source design. If your browser has event source, it uses that and effectively becomes a no-op style wrapper. If your browser doesn't have event source, it emulates it using native jQuery. So we can literally just say, cool, give me whatever was in my request to start with, and then connect to the event stream and start receiving new events. The flash messages is also cleared at the end of the request. So every time we reconnect, this would be empty. We could also just keep it alive forever and never flush it out or save it to an object, depending on what you want to do with those messages. If you're being, I guess, Facebooky, you would actually write them to a database. And then when you wrote, you would use the save signal to track when you updated that table. And then you would have that cough the messages out. But I used this because it was here. So executing this example, which is number 6, this has the tricky step that I delivered the dependencies via Bower, which if you're not using it and you're in the web world, then you've got to start using it. Bower is if pip is package management for Python, then Bower is package management for front-end JavaScript. So you can go Bower install jQuery or Bower install whatever you like. If you look in the top level there, there's a bower.json file which tells you what packages we're using and what versions of those packages we're using. So it makes it so much easier, particularly in a big web app. You're going to depend on Angular maybe, or Bootstrap, or jQuery, jQuery UI. You're going to depend on so much stuff. And this way you don't have to care. You can just have the versions in a file. Someone wants to change a dependency, change the file, run the thing. It's package management. Then knocked together this very quick little collect static that will pick them up from Bower and copy them into our static location, which is a thing it defaults to, in this case, web app static on somebody else's server. Hopefully they'll give us an environment variable that tells us where it is, or some other documentation to say, hey, put your static content here. By static content, for the non-web apps in the room, web devs, I mean the stuff that isn't being generated by the server. So all your images and your JavaScript and your style sheets and maybe even some of your HTML, depending on what you do. Alternatively, if you think that was kind of crack and you hate it, then, whoops, what did that do? Then there is WebSockets. This requires a plugin to gEvent or another server capable of adding a WebSockets middleware. It also requires a browser that supports it or a shim. People always say to me, like, oh, why aren't you using WebSockets? And I'm like, I don't know. It's still kind of new, and I'm can't be bothered changing a lot of code. That other one will work everywhere that you can do Ajax. So I've just totally lost my thread. The other thing about serving in production for the thing is you don't necessarily need to care about killing all the old event stream threads. You can just let the server reload, let those old threads keep serving what they were serving. When the user leaves the page and the connection drops, they'll be cleaned up and respawned, running the new version. How are we going for time? We're about an hour through. Cool, I think we're just on about time. So we've done all this. We've written this really cool app. It's got all these cool things. So we want to do some testing. I personally really like py.test. Of all the test frameworks, it's my favorite by far. Some people think it's crack. Those people who don't like magically fiddling with the assert keyword and doing creepy stuff that you don't understand deep down in the Python interpreter, I like it. You could easily do these same examples with nose or with Python's built-in unit test. But I think py.test is pretty cool. So Flask provides us with some utilities to make stuff easier for us. The most important of which being a test client, which will do HTTP requests to the Flask application. So what we can do is create some fixtures in py.test, which we've made available to all of our tests to do the things we need them to do. So the first one, you can see these are session fixtures, which means that they'll be created once and constantly reused. If you need, you can make them, you can change the scope. They can be module fixtures or they can be single test fixtures. I was like, I want to know what happened. Like if I jam my state, like if my state can't be reused, I kind of wanted to know about that so I don't recreate them. So the first thing that I do here is I spin up a fixture for the database. I say, yeah, it's a testing database. I give a URI, which in my example is an SQLite memory instance. There's two schools of thought here about how to test things against a database. My school is test on the thing you use on. So if you use Postgres, test on Postgres, create a second Postgres database and test with that. Because if you go through and you write all your unit tests against SQLite, and then you go and deploy to Postgres, and suddenly have real types and real like transactional semantics and like real constraints, and you go, oh, but it works in the unit tests, doesn't help you. So create even if on your test harness you have to spin up a Postgres server and create an empty DB, do that. The nice thing about here specifying the URL is we can say, cool, okay, it's called myapp_test. Tools like Travis, if you're doing CI on Travis, has a thing go, oh yeah, I want a Postgres 9.2 server. And it will just do that for you and pop out an environment variable saying, here's your test database. I think I've stressed that point sufficiently. Test on the real thing. We can then do a test of our view. So this one's pretty low tech. We just go and get the /URL, and we check that it has a title. Again, py.test does this magic assert rewriting. So if that's not true, it will give us a difference and highlight the bit that's different and all this other cool stuff. That kind of blows people's minds, but it's better than self.assert equal. And so we can run our tests like this. Ideally, if you run py.test, it'll go hunting for tests, but it has this bad habit of hunting for all the tests in your virtual environment as well, and that takes a while. You can control those settings. I just hadn't got around to adding it in this example. You can then go a bit further and do things like mocks, which I'm just going to show you an entirely different piece of code because I was struggling with it last night. I don't know, I didn't want this to be too much of a tutorial on how to do testing, so I haven't included heaps and heaps. If you would like this code, it's also on GitHub, and I'm more than happy to talk to you later on about how to do things like mocks. So this is a piece of code here that will mock in an entire fake OAuth server into the system. So we can just grab the Flask app, create some extra routes, fiddle with some variables that say where to go when you're redirecting, and then send back some fake replies so it thinks it connected to OAuth correctly and correctly authorized. And then I can continue to check that I do the right stuff once I've authenticated to the server. Again, you can do that sort of like the classic sort of stuff where you can control one end by making it do requests and then give it like fake the endpoint that it connects to and just send back canned responses. And you're in there go, oh, cool, yeah, and now do this. It's not a real world integration test, but this is unit testing. So that was a very quick tour of testing. And the final thing is getting an app into production. And so you spend a time writing this app, and it runs on the dev server that you've got. And you've got, OK, that's cool, and now where to go? And once upon a time, then, you'd have to get a server, and the server would have to be running Apache, and you'd have to have mod whatever. And nowadays, you can just go to someone like Heroku or whatever. And I like Openshift because they're from our friends at Redhat, and it's actually open source. You can run Openshift on your own hardware or your own virtual whatever. And it's nice. I also like that they call their plugins cartridges. It makes me think of my old 8-bit Nintendo. And so the standard Python cartridge is pretty easy. It has two basic entry points. One, when it builds, it runs setup py in your top level, which it expects to just be a standard setup tools or distutils or whatever flavor you want of setup py. And the other thing it will try to do is import WSGI application and use that as your WSGI app. The full documentation for being a Python developer in Openshift is that one. So setup py is easy. All I've done here is instead of retyping the requirements, I just read them out of the file, which is what that horrible little expression is. I sort of wish their thing, you could add to the build hook to do pip install -r requirements.txt, but I don't know. This is officially, like, it wants the list of requirements. This is the list of requirements. If I package it up, then this is the list of requirements. I could have put them in here to start with, but yeah, I don't know. This file is pretty much just copied from their base template. If you create a blank Openshift Python app right now, it will give you a whole bunch of files by default. And one of them is this file. The only thing that I've added to this is the last part where I grab my application and I instantiate that as a variable called application. So when it goes from whiskey.application import application, it gets the right thing. You could do whatever you wanted at the end here. Whatever you need to do at least. Yeah, this file basically just says, okay, my repository contains Python modules, and then I want the virtual environment. And then, I want to make sure in the virtual environment, cool, now import my code. The final part in my init py is I need to actually set up my configuration properly. So you can see here now that I'm getting my secret key. I'm making sure that I have defaults still so that if I'm running on my dev server, it still works. So I attempt to get Openshift secret token, which is a secret token they've assigned me, and hopefully then not something I shove in GitHub. I'm then getting their database connection string. And similarly, if that falls through, I'm just using SQLite locally because I'm a sucker for punishment. I should be using Postgres. But I didn't want to start Postgres on my laptop today. So the only reason I didn't is because then what usually happens is at some point I reboot my laptop, forget to restart Postgres, and go, why doesn't it work? Yes?
Is the normal way to bring that secret token into an environment variable?
It's one way. The way we actually use at work is that Puppet deploys a Python file in with the rest of our settings. We have a setting like a config.py. It then gives us a Puppet config py. And at the end of config py, we go import Puppet config.
Okay. Yeah, because people on your machine can probably find out what that value is.
People as this user could find out, but this is an LXC container, so it's safe. It's a good point. If you're on a multi-host machine that other users can log into, yes, they can go to proc blah env and get your environment. And so that would be insecure. In this case, this is how they give it to us, because these machines are LXC containers on a machine you can't access and don't have privileges.
Okay.
I think also to get someone's environment, you do need to, I don't think.
I don't remember for sure. I'd have to check. I don't have on that public check.
Yeah, it depends on your permissions whether they get someone else's environment, but it is an exploit. In this case, this is how they do it. And it saves me having to generate a key.
Good.
The other thing I do here is I set my, oh, it's fallen off the edge of the screen. I set my static directory to be, Openshift say that for your static content, they want it in the directory whiskey/static inside the repository directory. So I've said if I have a key called Openshift repo dir, then I want my static files to be in Openshift repo dir /whiskey/static. And then when in my build process I run that collect static command, it'll grab the files that I want from Bower and put them there so they can be served out to people. If they do something weird, like say they want it in whiskey/static, and on the web server they serve it as /assets, something like that, there's another setting you can pass to Flask, which says that my assets directory will be in /assets. If it's coming from a CDN, you can do a very similar thing. Or at that point, you can probably just fix it in your code.
Wouldn't you serve the static assets from the web server rather than through Flask?
They are being served from the web server. This is just so Flask knows where they are. So there's a command called find resource, which will tell me where on the disk they are. And then there's another one called static URL. I can't remember what it's called. I know what it's called in Django, but that will tell you where on the URL tree they are. so that you can do the right thing. And that way, when you deploy to different environments, you still get the right stuff based on your config. Or you can just hard code it all in your template. But eventually, you'll regret that. So the other thing I forgot to say before this talk is, hey, set up Openshift if you wanted to deploy it live. How much time do we actually have? Not
20 minutes.
really 20 minutes.
I think so. It's 3 it finishes, is it?
Oh, is it? Nice. OK. Do we want to do this? Do we want to see how much it screws up? Look at that. I'm probably even logged in. RHC, app create example. So this is saying that I want a Python 2.7 app that I'm calling example. The no git thing just says don't try to check out the git repo because we're already in a git repo. I have an outstanding complaint with them that it should use the git repo you're in if it looks like you're in one. So that's just going to do some stuff. I've said by default, I don't want it to scale. I don't want it to hot deploy. All these are things you can eventually do, but we won't do them today. This is also using a free account, so I don't know that I get scaling. While that's doing its thing, which could be a couple of minutes, depending on how loaded their new VM spinner upper is. Does anyone else have any other questions so far? Yes?
Thanks for a really nice overview of how to do it. Is it possible to actually download your code?
Yes, the code is on... no, stop that. It's got this idea that it doesn't have my public key, but it does have my public key. So it just created me a new key for a thing I don't even want. What's scary is I'm pretty sure if I'd already had a key called ID RSA, I'm pretty sure it would just tried to upload it to Redhat. I hope that's a... The tool is written in Ruby, so I shouldn't think so. It seems to be a new thing. So maybe Redhat have decided to hack us all by stealing our public keys. So we've created an app on the server, which if we... By
the way, apparently you can scale up to 3 keys.
Oh, yeah. So gears are the things that run... Gears are the things that run stuff. So a single web app might be a gear, or a Celery queue runner might be a gear. And so I think the reason I can't scale also because I have no other gears left. This is my demo gear. So it dropped us in with that, that uninspired bit there. So if I then, oops. Somewhere here it should have my Git URL. Where's my mouse? So they've created me a Git repo. So if I go git remote add RHC, that Git URL. So the other part that you need to do is you need to add a database cartridge. They've recently added Postgres 9.2, so you can stop punching yourself in the face. When I first started using Openshift was because Heroku wanted $200 a month for me to have PostGIS. And I went, oh, that's amazingly cool, because Openshift will give it to me on a demo, and they won't shut my VM down every couple of hours. But then I discovered it was Postgres 8.3 or 8 point whatever. And I was like, particularly because that's PostGIS 1.5, which is especially horrific. So that's now spinning up a Postgres server for me and taking up some time. You can add a number of these cartridges. Unfortunately, what you can't do if you're into it for some reason is have a cartridge that has both Python and Node on it at the same time, which is a thing that maybe I tried to do. Yep, so that's cool. So now if we go git push force RHC. So we just blat its copy of master with our example 0.8. Yes?
I noticed the syntax for Flask is so similar to Bottle. Is there, any history of that, those two projects?
Bottle is a fork of Flask, as I understand it. I couldn't tell you why that is. I've personally never used Bottle outside of one. I went to a thing on Bottle and Python 3, and I was like, oh yeah, it's just like Flask. So I couldn't tell you about why or wherefore. So you can see here, because we've done our push, it's doing our build process, sort of run setup py install, and it will then run the contents of some other files, which are I'm on the wrong branch. I think that's it's a classic one over the years of it, when everyone switched to Git. The most thing said commonly in presentations now is, I'm in the wrong branch. So we've got these pair of files, and these are just executable scripts that will do stuff that we want Openshift to do for us. This one when we build, which happens when we do a git push, and this one when we deploy, which also happens when we do a git push, but later once all the services are back online. So you can see here it's kind of still doing that initial build. It's very confusingly installing Bower from npm, because Openshift also don't provide Bower in their default image. So they do provide npm, so I just went npm install Bower. If you need deps that otherwise aren't available, that's actually kind of a pain in the neck. That's the problem with platform as a service. So that'll keep doing its thing. Those little build scripts are pretty straightforward. We're just saying, cool, add npm's executables to my path, set this variable to make sure it's somewhere that's writable. Not all of Openshift is writable by various people. Then install Bower, install Bower's dependencies, install that into my app. And then once the database is back online, upgrade the database to the latest version of the schema. If I ever need to do something as horrible as a downgrade, I would have to do that manually. The interesting thing to note with these tests is in my test harness we did before, I wasn't testing the migrations. If you are a purist, you should at some point also write a test that tests the migrations actually work. And then if you're an especially purist, you write a test that tests you can go backwards. But often my opinion then is you do your upgrade in a transaction. If it fails, you just stop and you go crap. You do your downgrade. No one ever seems to test downgrades. Just kind of, that's how it is. Ooh. And that just blew up. Ah. Apparently Bower in NPM doesn't run right now. So this wouldn't have finished deploying. That's awkward. Yeah, so it's blown up in a JavaScript error, and so it's failed to do that collect static because it's trying to ask Bower. It's going, all those dependencies installed, where are they? Okay, so that's actually not going to work, and that's a shame. As part of that, you can also kind of clean up your application. So this was kind of an initial cleanup I did, which you're welcome to kind of go through in your own time, have a look. In it now just has the config. Manager was all that Flask script stuff. We have models, views, and some extra bits and pieces. It looks very Django-y, but I write a lot of Django, so it's kind of how it happens. How much time do we have? We have 9 minutes. Cool. So what we did was very, very, very basic. If you were writing a 2 or 3 view app, that's great. There's not a lot of reuse there. There's a lot of other bits and pieces. If your app mostly just needs to be a little web adapter to some much bigger piece of existing work, that would be great. If you want to write a big existing piece of work on Flask, there's more you can do. The first one is something that a lot of people, when they hear this, go, which is class-based views. These came from Django. A lot of the Django people don't like them. I'm imagining a lot of the Flask people are also not going to like them. A class-based view is a view that's a class. Yeah. So you can see with this one, I want, a class called whatever. It's a method view, which is just a thing that will pop out some methods for my different kinds of requests. And based on what methods I define will be what kinds of operations I support. There's half a dozen of these built into Flask. You write your own, whatever. The reason these are cool and why they're nice in big applications is once I have this, I can override it. I can overload it. I can change it. I can do all that nifty object-oriented stuff. So I can have a generic get that goes, OK, load the thing that's in the class variable template. And that's all my base template handling done. And then all I need to do is have a class with a variable called template that inherits from template view. I can also then go, all my form handling can be one basic class. All my authentication can be one class. And if you inherit from that, then you'll be authenticated. And we can just implement methods to make stuff happen, return a list of objects, handle a single object. Anything that you want to do, you can then build as a child of some other class. And all that OO stuff can suddenly be applied to web programming. And that's pretty cool. The other thing that you can do is test them much more easily. I can instantiate this class in the regular way, and I can then poke the methods individually in my unit test. So if I have a method that instead of taking in a full-blown request context, takes in some data out of the request context, I can test that method in isolation of needing to do a full HTTP request, which is nice for unit testing, makes it a lot faster. Other people just go, what on earth is that? It's really whatever you like. The Django community was like, whichever you prefer. And Flask people, this is quite new for them, but I think they'll come to the same place. The other thing is this thing called blueprints. And a blueprint is just a way to create a reusable blob of web app. So there are a couple of these now floating around on the web as little packages. So you can get like an admin blueprint, which gives you an admin site and does then a lot of introspection of the rest of your web app. And so you, instead of creating an app, you create a blueprint, and you kind of then do much of the same stuff that you do anyway. It has its own static. It has its own templates. And then you can kind of stitch them all together and create a full application. And even down to things like, you can say, when you add this blueprint, add it at this prefix. So here, what might be /page, whatever, some string. We can here add a prefix when we go register blueprint, simple page, prefix equals /user. And then the URL will pop out at /user/page /some string. And so that's pretty cool for writing bits of code that we can reuse, attached to multiple places in our app. If we always need some concept of a particular object attached to different parents, we can reuse it. And that will make your app much more maintainable in the future when you just go, why did I do that? So that's all I've got, and I think I've got about 4 minutes left if anyone else has any questions. Yes?
I might have missed it earlier, but have you got this up online somewhere where you can grab the source?
The question is it online? The answer is right there. The last letter that you can't see is an E. Yes?
Flask is single thread, is it not?
No, Flask is however many threads that you need. If you're running the dev server, you need to tell it that you want to have multiple threads or multiple processes, your choice. So that's a parameter. When you run it in production, it depends on how production is configured. But it is fully thread safe. It will do all the stuff that it's meant to do. Anyone else? Yes?
Do you have the slides up online as well?
Yes, they're actually already on GitHub.
Have you got them on your machine? Have you got them on your laptop?
They're a JavaScript program.
So you can't put them onto a USB, you can't put the lot onto a USB stick, that one in front of you there perhaps?
I could as a PDF.
Doesn't
Yes.
matter. What have you got, stick it on there if you would, please?
Okay. Yep. Yeah, so I'll add them. They're in a separate repo at the moment. I'll add them as a Git submodule. That repo is probably Danny/reveal.js, and it'll be the branch called Flask Tut or something.
How did you do the PowerPoint in JavaScript?
It's called reveal.js.
Oh, okay.
Check it out. It's amazing.
Third thing I've seen today use it.
Beg pardon?
I saw it for the first time today. It's that third presentation I've seen today use it.
Yeah, it's amazing. Oh, the JavaScript thing. It's called reveal.js. Cool. Any questions maybe about Python? Maybe if I unfull screen that, you'll be able to... Oh no, if I re-full screen it, then it works. Cool. Thank you very much.